Everyone. I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science. In this video, we are going to discuss about the sequencing problem. What is sequencing problem? Let I explain a small example about a sequencing problem. Consider a publisher perform two jobs. One is printing, another is binding. Suppose he published 10 books. The time required for printing and binding each book is known. He used the printing machines and the binding machines. Print first and bind next. The problem of publishers to be decide the order in which the 10 jobs should be done so as to minimize the total time taken for all the jobs. Such a problem is called a sequencing problem. The sequencing problem is the problem of determining sequence order of a series of jobs to be done on a finite number of service facilities so as to minimize the total time taken for finishing all the jobs. Before going to the problem, we have two important definitions. One is what is total elapsed time. The total elapsed time is nothing, the time between starting the first job and completing the last one. What is the idle time? The idle time on machine A is the machine idle during the total elapsed time. Now we discuss two machines and n jobs problem. There are 5 jobs, each of which is to be processed through two machines M1 and M2. Processing hours are as follows. Jobs, 5 jobs, and the machine M1 is time taken. Job 1 is 3 hours, job 2 is 8 hours, job 3 is 5 hours, job 4 is 7 hours, job 5 is 4 hours. On machine 2, it takes the first job 4 hours, and second job is 10 hours, third job is 6 hours, fourth job is 5 hours, fifth job is 8 hours. Determine the optimum for these 5 jobs and minimum total elapsed time. Find also the idle time of machine 1 and machine 2. Now we find the optimal sequence from this order. First write all these machines and the hours of M1, M2 in that all the machines. Now we take order of cancellation. Among this M1, M2 time hours, which time is minimum? First identify that one. Here on M1, the third 3 hours. M1, the first machine takes on M1, it takes only 3 hours. Therefore, we put it the first cancel. But it is in the first machine. Therefore, we put the machine 1 in the left side of the table. Next, we take another minimum duration time is after that it cancel. Then next minimum time duration is 4. 4 is fifth machine on M1. Therefore, we cancel the next one. Therefore, 5. And next, third cancellation is again third machine on M1. Therefore, we put it 3 in the left side. Next, we take next we take the next duration 8 hours, but it is on machine 2. Therefore, write it in the right hand side. Finally, we take this one. Therefore, the optimum sequence is 1, 5, 3, 2, and 4. So, to find the minimum total elapsed time, we write in the order of the sequence 1, 5, 3 to 4. First a time in the first time, the machine start in 0 time, and the timeout when you take the first machine on its total time duration is 3 hours, and after completed 3 hours, next we go to the next jobs. Therefore, M2 is 3 hours, and M2 finish the work in 4 hours. Already we have 3 hours, so 3 plus 4, 7 hours. Next we take fifth one on machine 1. Machine 1 timeout is 3 hours, and machine 1 takes the time duration 4 hours, so 3 plus 4, 7. On M2 we take this 7 hours. After completing the first M1, then we take M2 the 7 hours. On fifth job it takes 8 hours, so already we have time in 7 hours, and when it is complete, 7 plus 8, 15 hours. On machine 1, 7 hours. In third job, we take third jobs before starting 7 hours. After starting the 7 hours, then it completing with 7 plus 5 hours, so 7 plus 5, 12 hours. But we can't take in the machine 2 because already in the fifth job is running in the previous one. After 15 hours, then we'll start the next work. So 15 plus 6, 21 hours, likewise we all. Here, the minimum total elapsed time is 36 hours. What is total elapsed time? The time between all the workings, that is 0 to 36. Total elapsed time is 36. What is the idle time of machine 1? Machine 1 is running up to 27 hours, but in the total elapsed time is 36. So 36 minus 27 is equal to 9 hours. What is the ideal time of machine 2? In the machine 1 complete his job, then the M2 will start. Up to that level, M2 will be ideal. Therefore, the ideal time of M2 is 3 hours. Likewise, we discuss another problem. A, B, C, D of the task is up to I, M1, M2 is there. First we consolidated, we calculate the optimum sequence like this way. Yes. So write all the job sequence in optimum sequence order. Then time machine 1, machine 2, time in, time out also there. Here after calculating all that, then the minimum total elapsed time is 61 hours. The ideal time of machine 1 is 61 minus 50, that is equal to 11 time units. And the ideal time of machine 2, the machine 1 complete his first job, then the machine 2 will start, therefore 2 minutes. Thank you.